All right, we have example 8.2. So we're on page 3 of the 8.1 notes for Unit 4. We have another example about our new mobile homes. Consider that problem again of estimating the population mean price of all new mobile homes by using the table, the sample data in 8.1, table 8.1 on the preceding page. Let's assume the data is normally distributed and the population standard deviation of all such prices is 7.2 thousand or $7,200. So question A asks us to identify the distribution of the variable x bar. That is the sampling distribution of the sample mean for the samples of size 36. So we can do this by writing it out or by drawing a picture. We drew it as a picture in class with the penny example. Here we're going to write it in words. So the three parts that you need would be the population mean of all the x bars, and we know that that's equal to the population mean for the entire population, and that information we do not have. We do not know the population mean. The next piece of information, and oftentimes in these examples we don't know the population mean, which is why we are trying to estimate the population mean using our sample means. Secondly, we need the sigma of the sample means, and that's equal to the sigma, or the standard deviation of the population divided by the square root of n. So we have 7.2 divided by the square root of, we have a sample of size 36 divided by 36, so we get 1.2. So we have a standard deviation of $1.2 thousand. The third element you need is the shape. So the shape in this case is normally distributed. Part B asks us to show that approximately 95% of all samples of 36 new mobile homes have the property that the interval from x bar minus 2.4 to x bar plus 2.4 contains mu. Now notice that 2.4 is just equal to 2 times the sigma that we just found. So this is actually saying x bar plus or minus 2 times the standard deviation. So we recognize this as our 95% confidence interval that we did in the first example. So this relates back to our empirical rule where as long as the distribution is normally, has that normal shape, it's a normally distributed variable, we know that approximately 95% of the observations lie within two standard deviations of the mean. And so similarly, approximately 95% of all samples of 36 new mobile homes, I'm just going to leave that part out, 36 new mobile homes, I'm running out of room, have the property that the interval x bar, I'm going to just do plus or minus 2.4, contains mu, our population mean. So that was just like the example on the front where we said "95% of these confidence interval will contain that population mean," and I said that okay, if we had 20 of these confidence intervals, 19 of them would contain mu, one would not. And then use part A in the sample data to find a 95% confidence interval for mu. That is an interval of numbers that we can be 95% confident contains mu. And so in this case, we're taking that and just doing our x bar plus or minus 2.4. And our x bar is 63.28, which we found here on the previous page. So we have 63.28 plus or minus 2.4. And I do the minus end first, so that's going to be 63.28. Sorry, that's 2.4. Minus 2.4, which equals 60.88. And then 63.28 plus 2.4, which equals 65.68. So in terms of a picture, we can say from $63.28 thousand to $65.68 thousand, we can be 95% confident that mu lies in here, in between these two values. In words, we can be 95% confident that mu of all new mobile homes is somewhere between $63.28 thousand and $65.68 thousand. Note that although this or any other 95% confidence interval may or may not contain mu, we can be 95% confident that it does. So here are a few key definitions. The confidence interval, that is the interval of numbers obtained from a point estimate of a parameter. Right, our point estimate here being the mean. Right, the interval being these two values that occur when we subtract and then add the two standard deviations from the mean. Here we have confidence level, the confidence we have that the parameter lies in the confidence interval. So the confidence level in this case was 95%. We are 95% confident. And then the confidence interval estimate, the confidence level and the confidence interval. So this all together, this statement here would be the confidence interval estimate. So when you put it all together into one phrase. Last page. What if we took a different sample of mobile home prices? So of all of the mobile home prices, right, from our example here, from the manufactured housing statistics, if we took another sample of size 36, different values here, calculated the mean, it's already done for us, thankfully, 65.83, so that's slightly more, a slightly larger point estimate than in our first example. And we subtracted the 2.4, same, so the standard deviation of the sample means is the same, because remember that's based on the population. So sigma sub x bar is related to the population standard deviation and the sample size, and both of those are the same for both sets of data. And then, so you have your lower bound and your upper bound, and so this creates another confidence interval. Each new sample creates its own confidence interval, and you can see here, already done for us, are all of these different confidence intervals. based on all these different point estimates. So here's one sample of size 36, where the mean was $65.45 thousand. And then adding and subtracting 2 standard deviations, we can calculate this range. And then this is represented, so 63.06 right here to 67.85. And you can see this is slightly different than what we did in class, where the point actually indicates the mean. So it can be done in various different ways. And so each one of these intervals is represented with a line segment. And similar to what we did on the front, only a little bit neater, we have the population mean, which is let's see, I guess they are revealing to us the population mean at this point being 65. And you can see that this dashed line runs through almost every one of our confidence intervals except for this one right here. And you can see that the mean does not fall within that range. And so 19 out of 20 contain the population mean, which is actually 95%, which is exactly what we should get when we do 2 standard deviations from the mean. Now, again, note this phrase, margin of error. When we say x bar plus or minus 2 standard deviations, this part right here indicates our margin of error. And we'll talk about different levels of confidence in our next lesson. So again, this was estimating a population mean using confidence intervals.